Let us look at proposition number 10 of book 10 of Euclid's Elements. The proposition says to find two straight lines incommensurable, the one in length only and the other in square also, with an assigned straight line. So what the proposition is saying is, we are given a line A. We have to find two lines B and D such that one of them is incommensurable in length only and the other is incommensurable in both length and square also. Okay, so we have to find this D and A. Let's start off. Given a line A, that's all we are given. Let BC be two numbers such that the ratio is not square is to square. Number square is to number square. Now find D such that B is to C is equal to A square is to D square, which means A square is commensurable with D square and A square is to D square has no corresponding number square is to number square. Why? Because BC does not have a ratio which is equal to number square is to number square. A is incommensurable in length with D. Again, based on a previous proposition. So if A square is to B square has no corresponding number square is to number square, then A is incommensurable in length with D. Okay, now take a mean proportional E between A and D. Again, we know how to do that. So if we have this, we would have A is to D is equal to A square is to E square. And remember the actual reference to the propositions, I'm leaving it to the book. So in the book, you will have references to all the previous propositions. Okay, so A is to D is equal to A square is to E square. That means A square and E square are incommensurable. Why? Because A and D are incommensurable. That means A is incommensurable with E, and two lines D and E have been found incommensurable with A. Two lines D and E. D is incommensurable with A and E is incommensurable with A. So two lines D and D. And D in length only. So D is incommensurable with A, which is the length, and E in length and square. A square and E square are incommensurable. Since A is incommensurable with E, that means in length. And since A square and E square are incommensurable, that means in squares. So here in this proposition, basically what we are doing is to find two other magnitudes given a magnitude, where one of the magnitudes which we have found will be incommensurable with A in length only, and the other will be incommensurable with the given line in both length and square. So that is proposition number 10 of book 10 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.